Hi, I'm Rich with insideHPC. We're here at the GPU Technology Conference 2013 in San Jose. I'm here with Rob Farber. Rob is an author and he's an instructor here at this conference. And Rob, I wanted to talk to you today about, we've all read the headlines that came out of, the announcements from the show at Jensen's Keynote. But you were pointing out some things to me that actually have more significance to the HPC crowd. What do you think that is?
So I was thinking about what Jensen talked about, and I think the real story for me is actually what he didn't talk about, going beyond that. The first is with CUDA, which is CUDA on ARM. We're actually going to have cell phones that will be able to be programmed in CUDA. They'll have a high performance, I believe it's a Kepler GPU.
Yeah. So you're talking about the CUDA, the development platform.
The development platform.
It's just this little circuit board with a GPU and an ARM so that people can start writing code for this, right?
But what Jensen said is they're going to shrink that down to the size of a dime and put it in one of these. So We'll be programming in CUDA on these things with a Kepler chip. Inside. Okay. So if you think of the implications for augmented reality, for all these different applications where CUDA actually now starts running on this little personal supercomputer in your hand, the implications are wonderful. For example, with my book, I do a basic framework for augmented reality where you can actually watch the video. I could put this up and I could have the phone morph your head into a lion or tiger or other thing, and we can start playing an augmented reality game.
Well, that might be helpful in my case. But, so something like the Starry Night thing where you hold up the iPad to the sky and it tells you what stars you're looking at. So that's Google kind of idea. Yeah.
But the thing is, I wouldn't be using a GPS. Instead, I'd be using vision. So anything that I could do for augmented reality games, think for the Google Glass crowd, very high performance, low power consumption in a very tiny form factor. So CUDA is actually a very exciting thing that I think people should be lining up to get now, because that's how you develop your CUDA code running on ARM so that you can run on these devices, which I think is a pot of gold, because these are the mass data consumption devices of now and the future. Okay. On the other end of the spectrum, where Nvidia is looking at big data, and I'll be actually talking about this tomorrow, but what you want to do is, and we all know that GPUs are a little short on memory capacity and they're a little short on memory bandwidth. Basically, any good HPC programmer goes in and turns their compute bound program into a memory bandwidth bound problem. So I've been following these hybrid memory chips that are the stacked memory chips for quite a while. Nvidia is actually going to put those on in the Volta architecture. So what we're going to do is see a stacking of the memory chips going up, maybe let's 10 high. And if we figure that GPU memories or DRAM memory chips double in density by the time Volta comes out, that means a GPU would have 24 gigabytes of RAM times 10, or 240 gigabytes of RAM per device. Now that's really exciting.
So that gives you a lot of density in a small space of memory, but doesn't it do something for bandwidth as well?
Absolutely. In fact, Jensen mentioned in the keynote a terabyte of memory bandwidth per memory subsystem.
This is pretty incredible, because we just had the first guy walk through the camera shot. We just had the first supercomputer system that benchmarked a terabyte a second in a real application over at Blue Waters, right? This is I forget how many devices it takes to pull that off, plus a massive supercomputer Cray. But we're talking about a terabyte per second on a board from one memory stack.
On a board. Yeah. So if you think about it, that you'll have up to 240 gigabytes of memory on that board, with the performance of shared memory of a current GPU. Fast, really fast. Yeah. So suddenly for big data applications, now you've got big data analysis capabilities on the GPU and the mass data consumption for the consumer market. The money potential and the computational potential is there. The coolest part about these hybrid memory chips is that right now you really can't, it's a struggle to do sparse matrix operations and graph matrix operations. The cool thing about these memory chips is that they will respond better to random memory accesses. So you get much higher performance on those sparse algorithms, which means that suddenly I can be doing graph analytics, or the potential for graph analytics. I can be doing sparse eigensolvers very quickly. It opens up GPUs then to this whole class big class of important problems for sparse data operations. So that's actually going to redefine the GPU landscape in and of itself, assuming I'm correct that the latencies will be so much more friendly to these irregular memory accesses. Okay. So it's a whole new class of problems which are directly applicable to big data. So that's really exciting in there. So we have big data to big data consumption. Then I was thinking about NVIDIA getting into the video server market. And I started clicking on, I think, where the NVIDIA, or at least my story for the NVIDIA thinking. And the first is that I'm seeing large companies who want to do video on demand becoming very unhappy with the Hollywood model, where Hollywood owns all the content, they get all the money. Understandable. So they're starting to create their own new content.
So like Netflix creates a TV show like why am I drawing a blank on it? It's House of Cards. Yeah.
Yes.
Yeah, with Kevin Spacey. Yeah. So they create the content, they host the content, they have the customers direct model.
So what this opens up is that the Netflix, the Amazon web content delivery people, individual filmmakers now have a direct outlet to the internet. What they can use these NVIDIA servers for is their own IT shop. They don't have to have the expertise. They can be the artists doing the content, working with it. They're working with the latest state-of-the-art software. And it's a way of bypassing Hollywood and getting all this new content coming out on the web for video on demand. And in fact, by the way, the Netflix example is beautiful because Netflix watches where you do pauses and other things, so that's a big data analysis problem. So they start looking at the scenes that you like. So Netflix starts getting the feedback so they can tell their directors, you want to do scenes like this and transitions like this. It's another application of big data. It's beautiful.
And hosted in the cloud, by the way.
And hosted in the cloud.
Yeah.
The other is what I think that Jen-Hsun didn't mention, which I would have, but I'm not of Jen-Hsun's caliber, but there's a whole 3D manufacturing revolution, 3D printing, the revolution going on out there, where it's becoming a cottage industry to design your own widgets that you plug in and do things. Well, all of a sudden with this video content, interactive video content on demand, you can work with SolidWorks like what Jen-Hsun showed, and any mom and pop shop can suddenly be working with the latest state-of-the-art for a small fee using these NVIDIA web server delivery devices. And they're working with the latest software again. There's no IT shop. I just go in, I'm creative, I do this, you click on it, and it goes over to Kinko's or whatever or other place, pick up your widget, and start selling it. So
that's cool.
I see the multi-dimensions on this, and I'm actually very excited.
And in fact, I went. My favorite talk this week was a guy from Harley Davidson, and he's mocking up the new machines and doing great visualization, but they're also able to 3D print something that somebody sketched 3 hours ago. They can actually put it on a physical bike to see how it looks and feel right and make decisions in that kind of speed. And he said they're just blowing people away with that. And the GPUs make all that possible.
So anyways, I see a lot behind the scenes that Jen-Hsun didn't mention in the keynote that I hope that your readers found interesting and reviewers found interesting, because I think that there's a tremendous potential out here.
Well, hey, Rob, I really want to thank you for putting this perspective on things, and thanks for coming by.
Always a pleasure.
All right.